Hello friends, welcome to this new video on GloVe word2vec model. And first of all, happy new year. And in this video I'm going to explain you each and everything about the GloVe, which is a global vectors for word representation. GloVe is an algorithm which is an extension to the word2vec method for efficiently learning word vectors, developed by Pennington and al. At Stanford. It is a classical vector space model representation of words, and it is developed using the matrix factorization techniques such as latent semantic analysis. And GloVe is an approach to both the global statistics of matrix factorization techniques like LSA with the local context based learning in word2vec. And so without delaying the implementation of the GloVe, I'm starting with this new notebook. And so let's take a step by step and let's learn that how can we install a GloVe word2vec model from the Stanford website. So here before I'm going to implement it, I just want you to take to that page from where I am going to download this word embedding. So on the Google you can write GloVe embeddings and you will find here, this is the first link, nlp.stanford.edu, and here you will see that this is the page, okay, from where you can learn or you can read the introduction that GloVe is an unsupervised learning algorithm for obtaining vector representation for words. Training is performed on aggregated global word co-occurrence statistics from a corpus. Corpus is a collection of words for a specific domain. Like for SMS text classification, we have a corpus of the words that are incurred in the SMS text, right? So likewise we have so many domains like Twitter sentences, Twitter words, and mail specification, like we want to classify them into ham or spam, like that. So we have different type of domains in which we can use this model or these embeddings to any of the domains that you want, and the resulting representations showcase interesting linear substructures of the word vector space. So here you can download the code as well for this embedding, that how these embeddings were generated, and you can also download the pre-trained word vectors. So in this video I'm going to use the pre-trained word vectors, and here we have this Wikipedia, okay, and from this Wikipedia we have so many words that it comes with these dimensions, 50 dimensions, 100 dimensions, 200 and 300 dimensions vectors. That means that each word is represented into the fixed dimensions of vectors, okay. And here this is the size of this file, and I'm going to download this file. You can also use this GloVe 40 to be 300 dimensions or 840, or GloVe Twitter. This is the collection of Twitter words that are occurred in the Twitter tweets, right? So let's back to this my Google Colab notebook. Here first of all I'm going to rename it like GloVe embedding, right? So you can do as well with your with on your system with me, so that it will be easy to learn and implement it, right? So okay, sorry, this is the embedding, right? Now first of all, what we need to do to code, we need to use this wget, right? So wget, and then the name of that particular location or the path of that particular location, which was the NLP. If you remember, NLP dot Stanford dot edu, right? Dot edu slash data slash glove slash and then dot 6b, right? 6b, b is capital, and dot zip. And okay, now you run this run this code, and then you will find that it will take few seconds, almost 10 to 20 seconds, to get that 6 billion words of in that GloVe vector model. And this is a zip file. Here is been started and is downloading, right? So in between is downloading the zip file, so we need to unzip that file, right? So for that you can also code for a command. We have unzip command, okay, and then unzip GloVe, right? GloVe. So we have why GloVe. GloVe is the name of that file, and we have, as we know from this, if you remember, that it comes in different dimensions: 50, 100, 200 and 300. So we have these files, right? And all the files are starting with that GloVe, right? So that's why I have to write down here GloVe, right? And then start to match all the occurrences of the GloVe, right? So now the first file is downloading here, and then .zip, because these are the zip files, right? So we will wait for to run that cell, because it's not finished, and it's still downloading the GloVe file, right? So meanwhile we can also here use that, right? Import that GenSim library, because we need to use that library when we are going to converting these embeddings, okay, and using that embeddings for the in a particular file, right? So we need to import the import the GenSim, okay. Yeah. So we have already typed that, and it's almost finished. So let's wait for just few seconds. So I know that it will be a bit irritating for you when listening to this video, but it's okay, because we need to have some patience, okay, because without patience we cannot achieve anything in our life. So it's almost finished, okay. So now let's run it, and it just take few seconds, right? Okay, now we have these embeddings, right? Now we have to unzip this file, right? So just run it, and you can see here that we have this in this zip file. Within this zip file we have these different dimensions of the vectors, like 50 dimensions, 100 dimensions, 200 and 300 dimensions. That is already here. You can you can look back this page: 50, 100, 200 and 300, right? And if you don't know how is these dimensions, so I just want to remind you, and you can watch my videos, and I will share the link in the description, that what is the word embedding, and what the dimension means, right? So 50 dimension means that each word is represented into a length of 50, a vector of length 50, okay, or a size, or the vector size is 50, okay. So a word is represented into 50 numbers, which is which is organized or which is arranged in a vector of size 50 dimension. Likewise, for this we have 100 dimensions for each word, we have 200 dimension of vector for each word, and for 300 dimensions obviously the same, the word is represented into a 300 long 300 numbers long vectors. Okay, so dimension means size of that vector, right? So I will show you that how that word is represented into these dimensions, right? So after that, what we need to do, from Gensim library we need to import a function, right? So from gensim.scripts .glove, okay, .glove word2vec, right? Word2vec, because the this is the word2vec model, obviously the name is GloVe, right? So we need to import that function which is GloVe word2vec, right? GloVe word2vec, here is it, right? So if you run it, then it is successfully run, right? So now we need to use two files, okay, which is one is input file and one is output file. So input will be this dimension, right? So you can take any of these you can use any of these files as an input, and then it will convert into that, because it's a text file, right? So that's why we need to convert into the vectors, right? So that's why we are using this this function GloVe to word2vec, okay? So now we have this input file, GloVe input file. So let take it into a variable GloVe input file, right? And then we have this GloVe 6b, right? 6b and dot 300. Let's take 300 by dimensions vector, right? Dot txt. So let's run it. So here it is. Now let's another variable which is GloVe output file, right? And then column, right? So output file, in output file we need to use this word to vec.txt, right? So just run it, and then we need to call this function GloVe to word2vec, right? So we have this, you can read the definition here, right? Okay, now GloVe input file, right, and word2vec output file. So GloVe, we have GloVe this input file, and then comma we have this GloVe output file, right? So we have this file GloVe output file, okay, and then we need to run it. So here it's giving an error which is right. Okay, yeah, 6b.300d GloVe dot, okay, right, this is a mistake, right? So again, so here we have this this file converted into this GloVe output file. So now you can see that we have this much of words, 4 deck words, and each word is length of 300 dimensions, right? So now we have what we need to do, we need to use this file as a model. Okay, so this is a binary file, so we need to convert it into that readable file, because by using the binary files and into the word2vec format. So for that we need to code just 2 lines, that finally the model is ready. So from gensim.models, okay, we need to import the keyed vectors, right? Keyed vectors. So we have this keyed vectors, right? Here we have this. Now run it, and then what we need to do, we need to define that into a model, and using this keyed vector, keyed vectors, right? Keyed vectors dot load dot word2vec underscore format. Okay, format, we have this word2vec, right? Word2vec output file, right? So we have this word2vec, but right, we have the name is GloVe output file, so we need to GloVe and underscore output underscore file, right? Below underscore output underscore file, and comma binary equal to false, right? False. So after running it, our model is, so it's okay now, and the model is ready. So okay, this is that. Here we have this so we have this model now, it's executing, and it will take some time because it will load the entire these words, right? These 4 lakh words. Okay, so now, right, so this is your GloVe word2vec model, which is ready to use. You can use any data and to fit that data into that model, and you can generate your embedding, right, of that specific word, because we have these 4 lakh words in that, 4 like vectors for the words, right, for the unique words. So you can also check the length of this model by using the len function. It's already downloaded and it's ready to use, right? You can also check for the length of this model. So here we have this length of this model, right? So length of this model is right, so has no length. Okay, no problem. You can also use this so has no length function, right? So the we don't need to calculate the length, because of the length is already, we know that these are the 4 lakh words and each word is right. Okay, now to if we want to for any word, let's take an example for this model of this da word. Okay, da word, right? So here you can see that this is the embedding of this is a 300 dimensional vector for this particular word da. So So in that way you can use you can access, or you can see the vector for any particular word. So if I say that for that word, right, a word, right, so we have another specific this representation of vectors. This is 300 dimensions long. Okay, so watching, and